Hello everybody, welcome to the joint webinar with Celonis and Deloitte Center of Process Bionics. Before we get started, three things to mention. The webinar will be recorded and will be shared with you after this call. We will have a Q&A at the end of this webinar. During the webinar, all attendees except me will be muted. And after the presentation, we will answer your questions you've entered using the GoToWebinar panel. That's regarding the technical prerequisites here. Let's get started. So this webinar, as already announced, is about accelerating production performance with process mining. And during the webinar, we will, first of all, introduce today's speakers from Celonis and from Deloitte. We will introduce you to Celonis and to the Center of Process Bionics at Deloitte. And then we will show you what was our challenge. What is the challenge we are answering using Celonis inside a production environment here. And production environment means for us to improve productivity and quality. And for both, we will show you how we improve reliability and accuracy of production planning. We will show you how to drive production lines ability to execute with less scrap and less rework. And last but not least, we will introduce you how we are using process mining to improve quality of components, to improve the quality of our products here. Once we have introduced you to this application of process mining in a production environment, we will give you a deep dive regarding the Intelligent Business Cloud provided by Celonis. And we will have a further use case deep dive for processes we are not allowed to share with you directly based on the data we had, but we have prepared some nice PowerPoints for you. And last but not least, at the end, you should have an impression how we are able to enable frictionless production in a superfluid organization. Good. Let me introduce you to today's speakers. Here we are, ladies first.
Thank you very much. So hello, everyone. Thank you so much for joining us today. We are really excited to be hosting this webinar to talk to you about how Deloitte and Celonis are accelerating production performance by leveraging the power of process mining technology. So to introduce myself, I am a product marketing manager at Celonis and a subject matter expert for frictionless production, working with our clients across the world on optimizing their production processes, from production planning and the procurement of the right materials and equipment through production and all the way ultimately to goods delivery. Prior to Celonis, I was actually a management consultant for several years, helping my clients to drive their business transformations across procurement, finance, manufacturing, and a number of other areas. So very happy to be here today with Frank and with Marcus about how we're helping clients together. Frank, I'll turn it over to you.
Yes, and before I continue, Marcus Brentscheid.
Yeah, thank you. So I'm Marcus Brentscheid, also from the Deloitte Center of Process Bionics. I'm a senior consultant and my purpose is to drive innovation in process mining. So I have a background in artificial intelligence and digital innovation, and I try to use that for process mining to enhance it both in the terms of applications we use. So for example, bringing process mining to production, to change management, but also to employ new technologies like predictive analytics. And that's why I'm today very grateful to be here and share a few of the things we've worked on with you today.
Good. Last but not least, Frank. My background is now since 25 years working with SAP implementations in the area of production, planning, and supply chain management. My industry focus is on automotive and chemicals. And furthermore, I have experience as a business process manager, again with a clear focus on all supply chain oriented processes here. And in the past, I was lucky to participate in a lot of process mining projects, delivering also very good results here. So now I will hand over again to Divya and Celonis introduction.
Great, thank you very much. So for those of you who perhaps are not quite familiar with Celonis, we started off as the first commercial process mining vendor many years ago. We now have a solution called the Intelligent Business Cloud that brings the power of process mining technology to companies across the globe. We support clients across many industries. This particular webinar is focused on production, but we also support clients who are working to streamline their order management processes, improve customer experience, optimize for on-time delivery, or improve working capital with our underlying technology. And here at Celonis, we really believe that process is the engine of experience, and our goal is to turn those processes into extraordinary experiences for everyone. And if we can go to the next slide, this is a little bit about what the market is saying about Celonis and process mining. So as you can see, it's really an exciting time for us to be working with more and more companies to leverage the power of process mining technology to achieve better business outcomes. And when we move forward in the presentation, I'll talk a little bit more about the details of what actually the Intelligent Business Cloud is and how exactly process mining actually works. Frank, back to you.
Yes, now it's my task to introduce the Deloitte Center for Process Bionics to you. What is the Deloitte Center for Process Bionics? First of all, it's an integrated cross-functional team working with more than 150 practitioners on a global scale with process mining, implementing process mining, developing new functionality for process mining, developing new use cases here. Yeah. And this is then delivered based on a already matured infrastructure. So we have more than 10 Celonis instances where we are able to train and work on a daily basis. And as of today, we are working with more than 200 million process instances, and only for the Deloitte environment with more than 100 concurrent users here. Yeah. In order to deploy process mining in the last 7 years, Deloitte has developed several tools and methodologies to support our customers in a fast, reliable, and sustainable implementation of process mining here. Yeah. And with our experience, also with a partnership with Celonis, we have now, since the beginning more or less, yeah, we are able to use process mining to the full extent. So now talking about the challenge or what's going on in production, what is the reason for production guys to utilize and deploy process mining? Yeah. It's all about complexity here. Yeah. If we now look at production from a perspective of strategic requirements, yeah, what we see now is a lot of transformation, a lot of disruption, yeah, driven by Internet of Things, by standardization, by a digital supply chain, connected devices, customer centricity, deployment of cloud applications, globalization, and of course, greetings to Greta, to green. Yeah? And all of these strategic requirements are related to structures, processes, and systems. That means a production guy has to deal with integration to other functions like warehouse, like sales, like purchasing, like other production units. Yeah, we have to take care of different production lines. Yeah, sub-assemblies, final assemblies, foundries, paint shops, and so on. Yeah, And all of this happens on a global scale. That means we also have to consider different geographies. We have production plants, for instance, in China, Germany, and US. Yeah? These we have to standardize, we have to get reports out of these different geographies, functionalities, and also production lines. So now a little bit more concrete regarding a client and the challenge. Yeah? The client we are now talking about and where we brought examples with is, in a scenario world, a typical European automotive producer. Yeah? This typical European automotive producer has different production sites on all continents except Antarctica. Yeah? So here we are talking about a 30 production sites environment, yeah, driven by many different systems, not only SAP or one MES. Here we are talking about MES systems. Here we're talking about PLM, QM, SAP, Oracle, you name it, systems. Yeah? And of course, in such a scattered environment, we see a lot of silos. Yeah? QM has a data silo, production has one or more data silos, sales has a data silo, and so on. And here, with a standard traditional legacy setup, we don't have any view on end-to-end processes. That means from sales through production to delivery. One example, or from production through purchasing back to production. Yeah? And this is then also the challenge for us, and why production IT engaged Deloitte to enable different departments to create a real integrated end-to-end view on processes, allowing them to drive efficiency and effectivity in the production results and the process here. Yeah. Key pain points of our customer have been high number of lost parts in the production process. We had high scrap rates without identifying or without an identifiable root cause. And of course, a huge gap between the original production plans and the execution of production, with an impact on service level to customer, as well as with a huge impact on working capital on the supply side. So, next slide. What is a typical production process? A typical production process, you see a lot of different production lines, you see a lot of different events, you see a lot of different activities in sequence. And on the left side of this slide, you see example for a production line in a paint shop connected to a plastic molding and to sub-assembly here. Yeah. What are the typical areas of impact? Where was it possible to generate a positive impact for the customer due to the application of process mining? First of all, it was all about efficiency. Efficiency measured in terms of rework and in terms of bottleneck identification. Second, and this goes together with process compliance, process adherence. Yeah? How accurate was the process executed? Was it as stated in the SOPs for your production, or was it more or less a Banana Republic freestyle production? Everybody is doing what he wants. Yeah? Then it's also necessary, or it was also necessary for us to check what is IT doing in the background. That means it was also possible with process mining to monitor IT activities and to check, based on process documentation, how IT was utilized in terms of compliance. Then, very important point for all of us, production quality. Yeah? What we needed was a root cause analysis, an error analysis, not only for a defect or a defect part, yeah, which needs to be scrapped, but also errors in terms of planning accuracy, as well as analytics, why a part was scrapped. And at the end, and this was the overall target, it was possible to reduce costs for production as well as reducing working capital. Yeah. We have some figures based on our experience. That means it was possible during the project to reduce lead time between process steps by maximum 30% here. Or it was possible to reduce 10% of your rework. And this is not only an example for one customer. We saw this in a lot of projects, yeah, to raise this potential to go into root cause analytics, allowing you to define measurements and later on to prove the value and the impact of these measurements, again with process mining. So now I want to give you a short live demo. What are we able to do here? And I'm switching now to our demo server. I hope everything is working. It is. Yeah. I see a lot of lucky faces here now in my room with my colleagues. And what is the starting point? Once you've told your IT and Deloitte, come on, start process mining now. Yeah, extract the data, transform the data, load the data, present me the data. What is the first thing you would see as a production responsible person? And one of the first dashboards we will present you is this variant or overview dashboard. And what do you see here? First of all, top line is that within this dashboard, we have processed more than 50,000 orders. Yeah, we have here some KPIs. Yeah, for instance, an automation rate, average throughput time, and of course, a value we have produced. In this case, close to 59 million euros. Yeah, and we see here a typical sequence of activities. And in this case, I only display you typical planning relevant events, yeah, like a planned start date, planned end date, actual start date, actual end date, and of course the delivery date. Yeah. What we see here, and this is completely untouched, nothing programmed, yeah, just the first look. Wow, this is the process as I would have expected it. Yeah? We have a planned start date, close to this is an actual start date. Hey, nice. Yeah, then we have a planned end date, and sooner or later we have delivered everything. Yeah? This looks like SOP. This looks like ISO 9001. Yeah? But, and this comes now here into the game. For this 15,000 production orders, we have more than 1,200 variants. Variants means different sequences of activity. Yeah? And with this most common variant, we only cover 20% of the entire production volume. Yeah? But what are now other variants? Let me show you two more variants. We see here, now we are covering 31%. And now you see, ooh, this picture doesn't look really straightforward compared to the first one. Now we see a little bit more of the typical chaos we have in production environments. Yeah? For instance, we see loops between planned end date and planned start date. Yeah, we see loops between the order finish date and the end date. Yeah. Sometimes we see an actual start date and actual end date, but there's also an option that we don't see this. Reason for this is, in some cases, order confirmations are locked, in some cases not. Yeah? Especially if you think about rush orders, or if you think about a lazy foreman on the shop floor. Yeah? He just enters the orders, close it immediately without entering confirmation, without processing data from manufacturing execution systems, without giving you the full picture about production. So, but going back to the first variant now, even here you see some hiccups, because when I talk about planning accuracy, at least I would expect that the planned start date would fit to the actual start date. Here we see already a deviation of 1 day in average. Yeah? Same here between the planned end date and the actual end date. So now you might say, come on, it's only 1 day. But if we are talking about a process with a total lead time of 10 days in average, like displayed here, then we are talking about a 10% deviation on each end of the process. Yeah? Here, the deviation means that you have material on stock too early, increase in working capital. At the end, it means that in some cases, if you have a very tight demand situation, your customer has to wait 1 day more for a car, for a mobile phone, for a computer, for a machine, whatever. Yeah? And this analysis is now possible only with process mining. And this analysis already creates data from a production planning system. In this case, it's SAP PP. Data from a purchasing system, SAP MM, and also from an SD system. So now you might say, hey, come on, show us the truth. I have by far more events in my game than you show here. Of course, you have hundreds of different events, different activities inside production. And for this variant only, for the most common variant, I will show you now the truth, the real chaos. Yeah? Here, in the so-called Process Explorer, we are able to analyze activities and the connections between activities here. Yeah? And if I now increase the number of activities, you see more and more your real world. You have partly delivered, you have partly confirmed orders. Yeah? You have so-called TICO, technically completed orders. You have deletion flags, you have a sales order created because something in production went wrong. Yeah? You have goods movements, and you have something very important, material availability. And one event we see quite often is that we start orders without a confirmed material availability. So here, the event is named material availability not reviewed. And this means for you that you want maybe to analyze a little bit further. And what we see here, if we just click on it, yeah, we see that in 78% of all cases, yeah, for a total production order, this could also be a production order network, yeah, at least one position of components was not reviewed or not confirmed. Yeah? And now this is nice information and you can throw it around, but nobody will react. How to react now on this not desired activity? First of all, create a filter. Just click on it and do a lot of SQL coding? No. Just select here, all cases. Now the process flow is adapted immediately to the filter condition you see on the top. Yeah. And now the entire dashboard relates to this special filter. Yeah. And now, then, it's possible to analyze, for instance, plant by plant, material group by material group, time by time, what happens here. Yeah. And talking about material availability, we are able now, here in this example, to check material availability in 3 different plants. One in the US, one in China, one in Germany. Could also be an aggregation, yeah, continent by continent, city by city, yeah, area by area, whatever. You see that we have different material groups here, yeah, and you see a lot of deviation when it comes to throughput time. Throughput time is here measured process start to process end. Yeah. And we see here, for instance, one material group. And maybe you've heard rumors, oh, this material group starting with 19 something, this creates problems. And we don't know why. In such a case, it's quite easy to filter and to dig deeper again without SQL coding. Select the material group here. So, store the selection or keep the selection here. Immediately, the chart is updating, focusing just on this material group. You see that inside US and inside Germany plants, we are producing this material group. And now we are able to compare throughput time only for this material group. In this case, it's the sub-assembly and in-house production part. What we see is that in the US, we only have one storage location where we store, where we transport, where we record this material. In Germany, we have 3 different storage locations. This is an indication regarding the complexity of your WMS system. And more important, if you look into throughput time for the same part, yeah, same customer group, same construction details, yeah, we see that in the US it takes us 8 days longer compared to Germany. Yeah. And now, again, we can move back to the so-called Process Explorer and Variant Explorer, and now analyze only the variants where, oh, wait a moment, Process Explorer, sorry, where we have problems with this special material group. And now, for instance, we see here that in some cases, yeah, we are reopening orders. Yeah, in some cases, we release in so-called order network. In some cases, we have loops here between delivery and confirmation. Yeah, and all of this sounds at least a little bit suspicious. Yeah, and in such case, either the system is not configured in the right way, or the foreman is doing this Banana Republic freestyle production. Yeah. And now in case you want to grab him, or at least you want to show him how to improve, yeah, then it's also possible to analyze case by case on a document level. That means you can now jump directly into the SAP system, see the related documents, analyze this together with your colleagues, and start improvement measurements here. Yeah. That's the first demo. Yeah. Of course, we have many more, but as an introduction for this short webinar, this should be good enough. If you have any questions, please state them in the GoToWebinar panel, and we will be happy to answer them. Good. Now, back to Divya.
Thank you very much. So that was really, really great to take a look through. So I just want to provide sort of a brief introduction to the Intelligent Business Cloud and process mining after the great example that we just walked through, just to make sure that everybody sort of fully understands the technology that was underlying what Deloitte was able to do there. So process mining works the following way. Every step that takes place in your IT systems, like for example, creating a production order, is a time-stamped activity within that system. Process mining takes the existing system data, recreates the steps that are in a unique identifier into an event log, and mines that data to visualize and analyze the processes in real time. So all of the visualizations that you see, this is not a one-time snapshot. This is as those processes are in flight, what do they look like? Celonis also leverages machine learning and AI to drive predictive capabilities to recommend and execute what we call next best actions based on those insights. And so what this visualization on this slide demonstrates is both the technology and the methodology that Celonis uses. So the underlying technology is process mining, and Celonis is able to connect through our powerful event collection capabilities to connect to source systems of any kind. So whether that's SAP, Oracle, JD Edwards, homegrown systems, various MES tools, it doesn't really matter if it's legacy or homegrown. All this information is collected there and then pulled into our Intelligent Business Cloud, where the extraction and the transformation of this data takes place extremely rapidly because we have pre-built connectors to connect to those systems. And then what you see overlaid as we sort of move up the screen here would be the three core elements of our methodology, which would be the steps that you take to discover, enhance, and monitor your processes to drive sustained business success. So discovering is really the objective visual presentation of the end-to-end process. So what Frank had showed in the Process Explorer and the Variant Explorer, this is dedicated to that effort of finding bottlenecks or inefficiencies, what we at Celonis call friction in a process. That occurs when there's some sort of breakdown or challenge in the ideal outcome that you're trying to reach. If something is slowing you down, if the throughput time is increasing substantially, it's also costing you money, but it likely is also leading to a poor employee experience on the production line. And ultimately, if it's allowed to cause delays, it's causing a poor customer experience, something that you want to get in front of. The enhance portion of our methodology talks about really sort of two things. One is primarily enabling better decision making because you're armed with these insights that we've just identified in the discover phase. And the second is around a platform capability that we have at Celonis called the Action Engine, which essentially runs in the background at all times, detecting variations in processes so that you're not only seeing these bottlenecks or inefficiencies and dealing with this friction, but you're really able to automatically detect those changes from an ideal process and have the Action Engine practically convert that insight into an action and approach the user or even trigger an action in the source system with the next best recommendation for what to do in that given situation. So scanning the process, finding an inefficiency, and directly converting that to a change initiative or an action. And finally, of course, it's incredibly valuable to be able to monitor the interventions that you have and the impact of these initiatives. One, to sort of make sure that your finger is continuously on the pulse and that you're able to take further action if there are any new issues that emerge that need to be taken care of, but also to enable you to show and to prove that the desired effect that you had wanted with that intervention is taking place for your organization and for your business outcomes. So what you see on the top line here would be, so if you want to improve working capital or on-time delivery or the customer onboarding experience, we have pre-built packages of content specifically for manufacturing, but also for other areas that pull together our process and program capabilities across discovering, enhancing, and monitoring capacities to accelerate your ability to solve targeted challenges in those specific areas. Frank, I'll hand it back over to you.
Yes, thank you, Divya. And now I would like to introduce Markus Branchard to you. He's the brain behind our most detailed and most successful use case. He will now present to you.
Yeah, thanks, Frank. So before we've seen how to analyze production planning processes with Celonis, now I'd like to show you a brief insight on how this might look like for production execution. So right now we are looking at a process in the MES system, and this is looking at the component production right before it's put into a car. So how does the whole process start? So first of all, you have just a bunch of plastic granules, which are pressed into a form, into a component form. So this is the first part of the process that we see on the left side. So we have quite a few steps in the actual injection molding process until the part is then put into the paint shop. In the paint shop, we have a long road with lots of process steps happening in between. Each one is measured, and these are also displayed here. So this is a very, very easy to comprehend visualization of the production process. And finally, after the part is being painted, hopefully just once, and there's no rework, then we finally move into the pre-assembly. So the part is stored somewhere. It's being planned for an actual car order and then put into the car and then finally put into the car before it rolls off. And this whole process we can see here with lots of steps on the left side, and we can see Celonis is really able to handle such complex and interconnected processes. And what can we do with this? Even if we just look at a few single steps, we can still already derive some insights from that. So when you look at the zoom in the middle, we can see that the part goes through the snow cleaning first, then it's treated with a flame, it goes into a primer section, then it's being dried, and then the drying is finished. And what we can see right here is, on one hand, we can see how long does it take for the dryer to prime, for the primer to dry. On the other hand, we can see how many parts we lose between each different process step. So this might already be cause for an investigation. And losing parts is not just one thing, but we can also look at the events themselves. And when we move on to the next slide, we have prepared an example on how we can minimize material waste just by working with the insights that Celonis can give us. So what we see right here is the scrapping inside of the paint shop. What's interesting is when we analyzed when does it actually happen. So the client where we went to, they of course have dashboards that show them how many parts are being scrapped in the paint shop. But what they didn't know is what happened before. Why were they scrapped in the first part? So usually you would assume they are being scrapped directly after quality inspection. And what we found out is that actually there were quite a few parts that were first put into containers and then later scrapped. So they used up unnecessary space, unnecessary capacity, and also it might be a sign that our quality inspection is not working properly. The next step where we identified that parts were being scrapped was after they were being identified as IO, which means they were okay, there were no quality issues identified, and then directly afterwards they were scrapped. So this means that the controls that were set up for quality didn't work properly. And these might be cases that we want to investigate. Why do these set up controls not work as intended? And finally, in the last step, we see there were parts that were being reworked and then later scrapped. So now we were thinking, does it really make sense to rework parts if they're going to be scrapped anyway? And this is why we did a deeper dive on that and looked at the interconnection between reworking parts and scrapping. And that's what we do on the next slide. Here we built a few dashboards to look at both the scrapping and the rework event. And we've seen that we had a scrap rate of 15.2 events and we had a rework rate of 1.1%. So there was not a lot of rework going on, but a lot of scrapping. And what we did was looking at them part by part. So we have some parts that are being reworked quite a lot, but they had a really good, a really low scrapping rate, and other parts were hardly reworked at all, and they had a really high scrapping rate. So this is what you see directly on the left side with these peaks. What we just then was just look at the parts that were being reworked. What's really interesting is when we look just at the rework parts by themselves, we see that there are certain parts that can't be repaired, that can't be salvaged anymore. So these are the peaks you see in the lower corner. Here we just selected of the parts that were being reworked, and we see that for certain components, it was just hopeless to salvage them. So for these parts, we could exclude them from rework in the future and directly scrap them in order to improve capacity and also to improve the usage of machines and material. And this takes us to quality. So we've seen we have quite a good understanding of how the process actually works, but what was really hard for the people that we did these workshops with was they already had information systems, but they only worked for silos. So quality was a silo, so they could look up a quality issue and get part numbers, and then they have to copy their part numbers into 3 other systems just to see the end-to-end process if there were some errors happening somewhere. And with Celonis, we could integrate all of the different information in one system and connect the error plot on the left side together with the process information on the right side. So what we see on the left side is actually, well, you can maybe see it from the shape. It's looking like a door. So this was actually a car's door. And what we'll see in the middle is that there were certain parts that were not being painted at all. So we were wondering, were these parts painted or they're not painted? And when we could directly go into the process and see that they were actually painted. And then we later found out there was something that was obstructing the paint in the actual process. So this was leading us to improve the hygiene protocols at the company. And this could also be an insight that was very hard to investigate if you don't have all of the information handy at once. So with this, I would like to close my short excursion on how we can use it for actually driving production quality and production execution. And now hand over.
Yes, Divya, it's you again.
Great. Thanks very much. So thank you for a really fantastic view into how this particular client was able to drive significant improvements across the board to productivity and quality. I think what we can all agree on is that there's sort of a really unprecedented capacity here to drive using unique visibility into exactly how the processes are running to be able to ultimately support significant advances to these top-line business outcomes. So as we continue the conversation around enabling what we at Celonis are calling frictionless production, what we hear from our customers is that the core areas of focus are really in exactly the areas that we've been talking about today. So improving productivity, minimizing scrap and rework, and ensuring quality, and that the opportunity on the table to see success in these areas is really significant. So if we can go to the next slide, we've talked a little bit about friction today and about how Deloitte was able to work with their client to overcome that. We have some additional examples of what operational friction can look like in other areas of the production environment here. So for example, a high scrap rate that comes from overproducing parts that become unused excess, or rework that takes place at a late stage in the production process because there were quality issues perhaps that weren't identified, quite as soon as possible. So ideally, what we want is to be able to operate fluidly without this type of friction getting in the way. And if we can go on to the next slide, we have 3 examples of exactly what some of our clients were able to achieve in this space because they were able to leverage Celonis. So here, I think first we can talk through A.O. Smith, who was able to see an improvement to their manufacturing throughput times of 30% by enabling more accurate production planning through the reduction of credit blocks that were impacting the order flow. So their production planners were having difficulty with the difference between the plan versus the actual. Their plans were not as reliable as they would have liked as a means of actually understanding what was likely to happen in production. And using Celonis, they were actually able to understand that the reason for that was that there were these credit blocks that were being placed upstream in the sales order process, and they had no real insight into when those blocks were likely to be removed, which made it very difficult to accurately predict when those orders would flow through, and therefore how you should plan for the production lines to be running or for materials to be requested in order to support that. But by identifying that that was a root cause that in some ways sits outside of the usual arena of production, but it was having downstream impact, they were able to standardize the processes, to streamline, and to enable better and more accurate production planning that ultimately increased throughput. So a little bit of a different story with BMW. So here, what they were finding was that similarly, there was a root cause behind the amount of rework that they were experiencing that they didn't have visibility to in the clearest way. So they had vehicles that were going through the paint process, and each time a vehicle was going through, it was meeting the KPI for how much time was really allowable to be spent in that particular process step. But what BMW didn't really understand and didn't have insight to was that there were vehicles that were going through rework multiple times, the same vehicle, for a completely unnecessary reason. And it was just the way that the process was actually running, even if it deviated from what the ideal path was. But by gaining this insight, they were able to collapse these unnecessary steps and essentially proactively eliminate this rework from occurring with any of their vehicles going through similar production lines going forward. And finally, to address really fully the topic of quality, with Eismann, they have some very specific steps, like I'm sure many of our other clients do, where there's a high need for precision at critical process steps. For example, enabling the gluing of certain adhesive applied parts within 1 minute of the prior step having taken place. And to be able to enable that, you need to have all of the right materials present right at the time that you're going to be taking that step. You need the product to be, passing all of the quality checks up to that point so that it's in the right place and at the right level to be able to proceed forward. And so Eismann was struggling with having to scrap parts that were not sort of meeting this quality threshold at this point due to the timing. And so by rebuilding the individual product lines and changing the process steps around this particular critical step, they were able to see significant improvements to their product quality. So these are just sort of 3 examples that we wanted to share. And I think if we can go to the next slide, I'd just like to make sure that we fully understand exactly how the Celonis technology and methodology operate to enable those outcomes. So what you see here is our connect, discover, enhance, and monitor methodology. And as we click through to the next slides, and the slide after this, you can see an example of one of the root causes that you might see in this space. So if we shift to the next slide, there's an example that I think we've touched on already today about how material availability could be a root cause behind a delay to production start. Now, if we think, and we go to the next slide, and we think about how Celonis might help to address a problem like that, one of the ways in which our customers leverage our technology is to say, now that we know that it's this particular material that's causing this production line that's important for us to not be able to start on time, we can preemptively alert procurement to prioritize PR to PO conversion, get that purchase order out the door for those crucial commodities, and realize an improved throughput time for those critical production lines so that you are identifying essentially the most impactful point of friction and then taking proactive steps to resolve. So that's sort of one concrete example. As we just discussed, there's a number of other examples. So what you see here is just a sample, but I would like for us to move forward to the Q&A. I know we have a number of questions that have come through that we would like to be able to get to and start to answer.
Thank you, Divya.
Thank you. Okay, I am just going to pull up the questions that have come in thus far. Okay, so I think one of the first questions that we came in was, can Celonis be used in a production environment that uses both repetitive manufacturing and unique sales order manufacturing in SAP? And the answer is yes, absolutely. We have customers that use us in both environments. So if you're interested in sort of just scenarios that have high product stability or high reputation rates, that's very common, but a number of our customers also leverage us for make-to-order scenarios. Frank, do you want to comment there as well?
Yes, one of our latest projects was about combining repetitive manufacturing environment with a make-to-order environment. So we have production lines where we started repetitive orders as well as customer configured orders here. Yeah, so we're also able to combine these 2 different worlds in production into one dashboard.
Great. Okay. Another question that's come in is, Do you have to check each deviation one by one, or is it supported by machine learning and AI so that you can sort of get a summary of the relevant results? And the answer here also is yes. Within the Celonis product, we have a capability called the Conformance Checker that essentially compares what is happening in real time against the preferred and ideal process path, and then identifies the most common deviations that you see and organizes them, in fact, by the percentage of cases that they impact and their effect on throughput time or their effect on certain desired KPIs. So you have a direct line of sight to what is having the most impact. And the Conformance Checker also leverages AI to perform root cause analysis so that without necessarily any analyst having to build a model, they can immediately understand it is this particular vendor that has the highest degree of violations when it comes to material availability. That material availability is in fact the biggest issue for this production line. Frank and Marcus, any thoughts from your side there?
Yeah, maybe just shortly adding. So I think you mentioned very well the capabilities we have from the machine learning side. And from our experience, I would also add that Celonis is very friendly for building dashboards by yourselves. And what we actually did in the production project, we actually went there with people from the shop floor, from the quality department, from the paint shop, and we were actually testing their hypothesis with dashboards they built by themselves. So you can build an overview how often you have a certain issue, and they were really able to test their own hypothesis, their own pain points, put them into numbers and quantify them just with a short training. So there's also a lot of subject matter expertise you can put into identifying issues and looking at them at a ground scale. You don't have to look at one by one, but you can really build dashboards and reports by yourselves and enable people from the production line to use them by themselves.
Mm-hmm. Great, thank you very much, Marcus. Another question was, are we able to monitor the process in real time, i.e. does Celonis have the real-time process monitoring capability? I think this might have been answered by me in some of the overview throughout the webinar, but the answer is yes. So Celonis uses continuous extraction from the source system data to be able to provide real-time analyses, impacts to KPIs, and complete monitoring. So that is 24/7 in the background running on the source system to be able to provide the most up-to-date information possible. So it's not static in really any sense.
And one remark from Project Reality, this highly depends on your IT infrastructure. For instance, if we have a punch card-driven mainframe system, which only is operated by batch runs, then each batch run will mean an update to Celonis and to our Process Explorer. In other cases, for instance, in a HANA environment or Hadoop environment, there it is possible to have real-time information, like for instance, is needed in a paint shop or in a process-driven production in chemicals.
That's a really fantastic point. So the Celonis is continuous in terms of how we pull from the source systems, but of course, there are going to be limitations from system to system based on how the system in question is collecting and collating and extracting data. Another question, so does the software work with any kind of system, e.g. mainframe, tailor-made, and how does the software identify the process flow that is mapped and monitored afterward? Is it automatic, or do you have to design the process and variables that should be gathered and analyzed? So another really good question, in fact, sort of three questions within the one. So the answer here is yes. Celonis is system agnostic, so we can leverage the technology across systems. The caveat would be what Frank had explained. So of course, there are limitations around the quality of the data based on what's captured within that system. But yes, we have a number of customers that have multiple ERP systems. I believe we have at least a few that come to mind that have more than 100. Some are legacy, some are homegrown. In some cases, it's SAP. In some cases, it's customized versions of SAP, but we work with all of them. The software the real value here in the discovery piece is that there is no work to do any process mapping workshops or to really have to kind of pull together the variables or the data or define the requirements or the process. It's something I'm very familiar with as a former consultant, but it's actually not required here. So the software automatically uses the data in the source system to reconstruct and visualize what that process looks like and how it runs. And I'm sure Frank and Marcus can comment on their extensive project experience in tackling exactly this.
Yeah, so from our point of view, usually we do the processing before we load the data into Celonis and aggregate it so we can directly map it to the customer's wishes, how they want to see that process, which business objects they want to have connected with each other. And for that, for example, customers set up a data lake or something where they collect the data from all of their source systems. We bring them into clean format and then analyze the results. So usually we use a layer in between.
Yeah, and again, a word from Project Reality. Yeah, we have seen COBOL programmed mainframes, yeah, programmed in the 80s, still working inside production and connected these mainframe data with SAP RPO, PPDS data for the experts of you, this fancy S4 HANA-driven planning system of SAP, yeah, and link this then also within Hadoop-driven MES system, yeah. So we've seen a lot of challenging cases, challenging infrastructures, but until now, it was possible to connect each of these systems.
That's great, thank you. I know we just have a couple of minutes until the end of the hour, so I'll just take one more question and then I think we can wrap up. But there was a question as to whether there, essentially how you deal with contradicting goals. So the fulfillment of an urgent customer order around customer experience via, or versus the increase of production costs by reshuffling the production plan. I think this is a really great question and I think speaks to the reality that many of our customers face, which is that at any sort of given point in the business environment, you are sort of faced with the choice of needing to optimize for a particular business goal. And the value of Celonis is that we enable you to do just that. So if you are interested in sort of ensuring that on-time delivery is the primary customer focus, that is possible. We can accelerate you toward that goal. It may well require a compromise in sort of an increased inventory carrying costs or similar expenditure. But the technology enables you to sort of understand what are the most impactful things you can do that are going to get you toward that outcome as effectively and efficiently as possible. And it enables you to do that in a continuous, rigorous, and data-driven way. Frank and Marcus, do you want to comment there as well?
Yes, so from Project Reality, I mean, sometimes this is also a very political situation. You might have a team that wants to drive the sales, for example, wants to fulfill an urgent customer order in time. And of course, the production unit is considered with the production costs and wants to avoid reshuffling. This is usually a heated political situation. And solving that is not done directly by Celonis itself. What we create with Celonis is transparency. We allow each side to show their numbers to generate an insight, what's the impact of reshuffling production plans, to show them what might be the impact of losing a customer. And that allows us to have a quantitative discussion between different silos. That's usually the starting point to see what's the bigger pain point. And really coming to a conclusion, taking an insight, that's usually an organizational measure. It's also something, let's say, it's a bit political, but I think what Celonis has shown that it can really greatly help is just by creating this transparency and lead to a data-driven or fact-based discussion.
Yeah. And one more story from a more operational point of view. I receive an urgent customer order, and in some cases it's necessary to simulate the processes. Yeah? What would be the effect of producing the same product in China versus producing this in Germany in terms of lead times, in terms of process throughput times? Yeah? And here we are able to use predictive analytics. So we are able, based on the experience from the past processes, from the past years or from the past months, to predict what would be the process sequence in future and what would be the final delivery date of such an order. And this goes together with transparency. And here it's possible to decide in a very conscious way, do I want to deal with higher production costs or with faster delivery? Yeah.
Great. All right, I think we are at time, but thank you everyone so much for joining and for all the great questions. Those of you who we were not able to answer your questions on this webinar, we will be following up afterward and be sending the recording out. But again, thank you for your time and hope you found something valuable in the session today.
Yes, thank you for your time, and also from Marcus and myself, thank you. And if you have further questions, connect with us via LinkedIn, via email, via phone, yeah, or drums, whatever. Yeah, we are happy to answer your questions.
Thanks.